Good day, learners! Now we have joint variation. This lesson introduces another type of variation, the joint variation. Here, we're expected to illustrate situations involving joint variation, translate into variation statement a relationship between two quantities, and solve problems involving joint variation. So what is joint variation? It is a variation where a variable varies as the product of two or more other variables. In symbols, z varies jointly as x and y, or z varies directly as the product of x and y is written as z is equal to kxy, or k is equal to z over xy, where k must not be equal to 0. Now let's consider an example. Find the equation of variation where A varies jointly as B and C, and A is 36 when B is 3 and C is 4. So for our solution, we translate A varies jointly as B and C into equation. So we have A is equal to KBC. Then we substitute the values of A, B, and C in the given equation. So our A is 36, B is 3, and C is 4. Then we have 36 is equal to K times 3 times 4. Therefore, we have 36 is equal to K times 12. 36 is equal to 12k. Solving for k, we divide both sides by 12. Therefore, k is equal to 3. So, k, or the constant of variation, is 3. To solve or find the equation of variation, we just simply substitute 3 in place of k. Therefore, we will have a is equal to 3bc. Let's have another example. If z varies jointly as x and y, and z is 60 when x is 5 and y is 4, find z when x is 3 and y is 7. Again, translate z varies jointly as x and y into equation. So we have z is equal to kxy. Next, substitute the values of z, x, and y in the given equation. Therefore, we have 60 is equal to k times 5 times 4. Therefore, we have 60 is equal to 20k. We divide both sides by 20 to solve for k. Therefore, k is equal to 3. And for the equation of the variation, we have z is equal to 3xy. Solving for z when x is 3 and y is 7, by substitution, we have z is equal to 3 times 3 times 7. Then we have z is equal to 63. Another example. The area of a rhombus varies jointly as the lengths of the two diagonals, and if a rhombus whose diagonals are 10 centimeters and 8 centimeters long has an area of 40 centimeters squared, find the area of a rhombus whose diagonals are 11 centimeters and 15 centimeters. For our solution, translate area of a rhombus varies jointly as the lengths of the two diagonals into equation. Therefore, we have A is equal to k d sub 1 times d sub 2. By substitution, 40 is equal to k times 10 times 8. 40 is equal to k times 80. 40 is equal to 80k. Then we divide both sides by 80 to solve for k. Therefore, k, or the constant of variation, is 1/2. Writing the equation of the variation, we will have A is equal to 1/2 d sub 1 times d sub 2. Therefore, to find the area of a rhombus whose diagonals are 11 centimeters and 15 centimeters, so we just substitute 11 and 15 in place of d sub 1 and d sub 2. Therefore, we have A is equal to 1/2 times 11 times 15. A is equal to 1/2 times 165, which is the product of 11 and 15. Therefore, 1/2 of 165 is 82.5. So the area of the rhombus whose diagonals are 11 centimeters and 15 centimeters is 82.5 centimeters squared. Now for your activity, answer the following. Thank you and God bless learners.